This week, we're looking at cognitive testing as well as neuropsychological assessments. We are spending a bit more time looking at cognitive or intelligence tests than neuropsych tests, although this will be a good introduction to neuropsych as well, and then we can also address that a little bit more next week. As a starting point, it's interesting to consider what our own definitions of intelligence may be. And I would encourage you to stop for a moment and think about how you would define intelligence. For a lot of people, they associate different characteristics with intelligence. And similarly, we may associate different characteristics with unintelligent individuals. A lot of these characteristics that we may come with their own social and cultural biases. So, of course, a lot of philosophers and psychologists and researchers and scientists have all taken their own whack at defining intelligence. And we see a few different definitions from some of the leaders of the field. Binet, for example, describes intelligence as a general ability to judge, comprehend, and reason well, whereas Thurston says that intelligence is the capacity for abstraction. Wechsler, and we'll be talking more about Wechsler in a little bit because he developed one of the most widely used intelligence tests, but he defines intelligence as the capacity of the individual to act purposefully, to think rationally, and to deal effectively with the environment. And then finally, Sternberg identifies intelligence as the ability to adapt to one's environment throughout the lifespan. So as we attempt to define and characterize intelligence, a lot of different psychologists and researchers have identified some different unique models of intelligence. The models that we are looking at this week are the psychometric approach, developmental progressions, information processing, and then we'll look at a few other theories as well. The psychometric approach is really based on the premise that intelligence can be described in terms of mental factors. And this is illustrated by Spearman's two-factor model, which was developed in 1927. So Spearman's two-factor theory proposes that intelligence has two components. He identifies one as the general intelligence, or G for short, and the other is specific ability, or S for short. He's considered to be the epitome of factor analysis. Spearman was the first to use mathematical methods to analyze and interpret neurological and cognitive function. He was also responsible for the discovery of general intelligence, or as he refers to it as the G factor, and he was able to do this with the help of factor analysis. So Spearman is a pretty big deal in the world of cognitive science. He was able to announce intelligence as a cognitive ability that is measurable. And that's how we today continue to use numbers to explain or measure intelligence. So Spearman really identified this idea of the G and the S because while evaluating tests of intelligence, he identified that scores of the same participants were similar in every test. And what I mean by that is that a person who scored really high on one aptitude test scored the same in another aptitude test. So on the contrary, a person who was really a low scorer on one aptitude test also scored lower marks on the other aptitude tests. And so this is what led Spearman to conclude that there's a factor between the intellect and the cognitive abilities of a person. And then he used factor analysis to examine these cognitive tests. After examining them, he concluded that the factors related to intelligence could be expressed numerically. Based on this, he proposed that the various mental traits are not independent of each other. There exists a factor, which is the general factor, or the G factor that he refers to. Conversely, we look at Thurston. And Thurston had his own approach and answers to all of this. Louis Leon Thurston, he proposed a multiple factor theory of intelligence in 1938. And before this theory was introduced, we were still looking at the G factor or general intelligence as being the go-to. But then Thurston brought in this concept of multiple factors associated with human intelligence instead of just one single factor, that general intelligence. He pointed out that every individual has different levels of 7 primary mental abilities. And so he broke intelligence down into verbal comprehension, word fluency, number, facility, perceptual speed, memory, space, and reasoning. He also found that these factors correlated with each other, so there appeared to be a general factor with 7 second-order factors, meaning he was taking the original idea of the G factor and saying that, okay, yes, my research also supports this idea of a general intelligence, but then we can break that general intelligence score down into these subsections, which may vary in score, but together equal that G score. The Cattell-Horn-Carroll model is, well, for one, the name suggests that it's a good example of everybody wanting credit for their contributions to a model, but more seriously, it's one of the more influential contemporary theories when it comes to cognitive abilities. This theory is considered the most comprehensive and empirically supported psychometric theory regarding the structure of cognitive abilities. So the CHC theory of intelligence represents a combination of the 2 previously proposed theories. So the CHC theory is still utilizing the idea of the G factor, but they proposed that G is comprised of multiple cognitive abilities that, when taken as a whole, produce G. And the CHC produced a model of general intelligence consisting of 10 items, specifically crystallized intelligence, which is considered comprehensive and acquired knowledge. Also fluid intelligence, which is reason and problem-solving skills. Quantitative reasoning, which is quantitative or numerical abilities. Reading and writing ability, short-term memory, long-term memory or long-term storage and retrieval of information, visual processing, auditory processing, processing speed, and then decision and reaction speed, as in coming to a decision and how quickly a person will react after coming to that decision. So while the numerical guys are developing these definitions and measurement of cognition, our developmental theorists are at the same time arguing that intelligence can be better understood by examining how intelligence develops over time. The developmental theorists argue that learning and environment influence the process and that information is really necessary to look at when considering a person's cognitive ability. So Jean Piaget, as we probably remember him as the guy who identified some core stages of development, he suggests that children move through these 4 different stages of learning. And his theory focuses not only on understanding how children acquire or develop knowledge, but also on understanding the nature of that intelligence. The sensory motor stage is birth to 2 years old. Then it moves into the preoperational stage, which is from ages about 2 to 7. Then the child enters the concrete operational stage, which is ages 7 to 11. And then formal operational stage, which is ages 12 and up. So basically, Piaget believed that children take on a more active role in the learning process, as in they experiment with the world around them, they're making observations, they're learning about the world and taking it all in. And as they interact with the world around them, they're developing new information. And so they're continually adding new knowledge and building upon their existing knowledge. And they're also adapting some previously held ideas to accommodate new information based on their new experiences. Another category of models trying to define and understand intelligence are the information processing models. And so these models focus on how individuals process information. And there are a few different theories that really fall under this umbrella of information processing. The first being Luria's theory from 1966. So Luria's brain functioning theory is based on the idea that there are 3 principal functional units of the brain, and those units of the brain are necessary for any type of mental activity. Under this idea, those specific units are responsible for walking, for obtaining and processing and storing information, for programming, regulating, verifying mental activity. And he also proposed that these units are hierarchical in structure. and consists of at least 3 cortical zones built one above the other. So within this unit, Luria distinguishes 2 types of basic activity, and he called them simultaneous processing and sequential or successive processing. So simultaneous processing is a mental activity that involves the integration of stimuli into 2 groups. And successive or sequential processing is a mental activity in which the person integrates or takes in stimuli or information and basically organizes it into a specific order. So the planning attention, simultaneous and successive theory, otherwise known as PASS, is another theory of intelligence. This one's really rooted in research on cognition. The PASS theory, this is really looking at 3 separate but interrelated brain systems that support 4 cognitive processes. So this theory really breaks down 4 cognitive processes as planning, attention, simultaneous, and successive processing. And then Sternberg's triarchic theory defines intelligence as the mental process that's used to navigate daily lives. So he said that people use these processes or components of thinking to problem solve. And he stated that there are 3 different parts to intelligence that could be referred to as analytical, practical, and creative intelligence. His theory is particularly important because it argues that intelligence is more complicated and diverse than a lot of the original thinking was. It applies a higher complexity to the measurement of intelligence than simply applying factor analysis. It's also important because he argues that intelligence is culturally constructed. And this is one of the first times that we get to look at and consider culture in the context of intelligence. So what is considered intelligent in one culture is not necessarily going to be considered intelligent in another. And so Sternberg really started to point this out, which of course started to trigger additional thought around the influence of culture and social constructs. There are some additional theories, of course, there are a ton when it comes to identifying and measuring intelligence. And again, the reason why these different theories are so important and relevant to all of you is because these are the theories that inform the measurement tools or assessment tools that we proceed to utilize in counseling settings. And so how we define intelligence dictates then how we would measure intelligence. So another theory of intelligence is from Gardner, and he presented the concept of multiple intelligences. Word Gardner suggested that there are multiple different types of intelligence, and he broke it down into 8. So I like how everybody basically kind of identified their own categories. And so Gardner had 8 originally, and then he introduced a 9th. So his list of intelligence types, or frames of mind as he called them, are visual spatial, linguistic verbal, logical mathematical, body kinesthetic, musical, interpersonal, intrapersonal, and naturalistic. And then he argued that there's a 9th that is existential. Gardner has acknowledged that multiple intelligence should not be mistaken for multiple learning styles, and his theory was not attempting to identify a correlation between intelligence styles and learning styles. His theory has also been criticized by a lot of psychologists and educators, specifically saying that his definition of intelligence is too broad and that the different categories that he identifies as intelligence are better described as talents or personality traits and abilities. And apparently Gardner's theory also lacks very much supporting empirical research. So based on this vast variety of theories and interpretations of intelligence, naturally then there are going to be a large number of different kinds of tests with which we could measure intelligence. This page displays some of the more common intelligence tests that we will encounter in the field. The Stanford-Binet intelligence test is an assessment tool that takes about an hour to complete, And this one assesses the level of intelligence across several age spans and several ability levels. In this test, it starts out with easy questions and then it progresses into harder ones. The level of difficulty of the test itself is adjusted for the ability and the age of the person that's taking the test so that they don't become too frustrated or start to quit because the test is getting too hard. So the Stanford-Binet looks at intelligence in 5 areas, and each of these areas are broken down into subtests, essentially. And each of those subtests are given in a verbal or a nonverbal method, depending, to accommodate very young children, even like 2-year-olds and people who don't read. And so the 5 factors for both verbal and nonverbal areas that he identified are fluid reasoning, knowledge, quantitative reasoning, visual spatial processing, and working memory. Fluid reasoning is the ability to solve problems on a spontaneous level. To measure knowledge, the test assesses what the subject knows about his surroundings and how things are done. In terms of quantitative reasoning, that's measured in terms of how well the test taker can use math to solve different kinds of problems. So more like a math test, essentially. The visual spatial reasoning portion of the test looks at how well the test taker can move or manipulate figures or shapes that are represented as multidimensional. So looking at 3D objects or pictures and kind of figuring out what the reverse of it would look like or would look like in sequence to another. And then working memory is assessing how well the test taker is able to recall facts and objects. The Stanford-Binet is one of the intelligence tests that does utilize basal level, ceiling level, and routing tests. So basal level just means that there's a base level criteria that has to be met for testing on the subtest to continue. So if the person doesn't meet the base level of criteria for the knowledge subtest, then the test is not going to be considered reliable or valid for that test taker. So in order to proceed with the test, they would have to meet that base level criteria. And then ceiling level basically means that the test kind of stops measuring when the test taker fails a certain number of items in a row. Let's say it's 5 questions in a row incorrect, then that would indicate that the test has gotten to a level of difficulty that surpassed that test taker's intelligence level. Wechsler scales are another series of intelligence tests that are really widely known and utilized in the field. These scales provide an estimate of global intellectual ability, which we refer to as the full-scale IQ. The full-scale IQ is broken into 4 composites, and the first one is Verbal Comprehension Index, which measures the ability for a person to apply verbal skills and information to problem solving. The next is the Perceptual Reasoning Index, which measures the ability for a person to engage in nonverbal reasoning using images or visual stimuli. The Working Memory Index is the third, and this measures the person's working memory or their short-term memory. It also measures the ability for sustained attention and auditory processing. And then the final index is the Processing Speed Index, which measures a person's visual motor coordination, their attention, their concentration, and how quickly they are able to process information. The Wechsler scales are very widely used in the US, but they are considered to be less reliable with individuals who present with IQ scores that are less than 50. And the Wechsler scales have also recently been criticized quite a bit for being culturally biased. With that said, it is such a widely used and studied method that the Wechsler scales are considered a very reliable and valid tool in the United States, at least, for individuals with an IQ over 50. So like the Stanford-Binet intelligence test, the WACE also uses base and ceiling levels, which does make it considered more reliable and valid of a test. It is another measure of a full-scale IQ, and the WACE is comprised of 10 core subtests that yield a 4-factor index scores, and those are verbal comprehension, perceptual reasoning, working memory, and processing speed. And then those indexes are combined for the individual's full-scale IQ. There are also 5 additional subtests that can be used as an alternative to the main subtests. And these supplemental ones are used to overcome problems like illness or absences that would prevent the person to otherwise complete the test in its entirety. So a person who maybe has problems with motor skills and as a result is unable to complete the block design subtest, they would then not have to take that test. They would instead get to use one of these supplemental subtests that doesn't require motor skills. The WISC, or the Wechsler Intelligence Scale for Children, is another widely used full-scale IQ measure for children. This is also individually administered, so all of these tests so far that have been discussed are tests in which they're administered to one individual person. And this one is designed for children between the ages of 6 and 16. And subjects over the age of 16 are generally tested with the Wechsler Adult Intelligence Scale, which is the WACE as opposed to the WISC. There's a little ones version as well. So children who are ages 2.5 to 7 years are tested with the Wechsler Preschool and Primary Scale of Intelligence. And the WISC also utilizes these index scores, the Verbal Comprehension Index, Perceptual Reasoning Index, Working Memory Index, and Processing Speed Index. And so the type of questions in each of these subtests are designed to specifically measure that index of intelligence. So, for example, to measure Verbal Comprehension Index, individuals that are taking the test will be looking for similarities between words. There's a lot of vocabulary testing and also reading comprehension. Perceptual reasoning is addressed with things like block design and pictures. Working memory index is addressed with things like digit spans or a series of numbers that the person has to remember and then repeat or finish the series. Same thing with letter number sequencing, kind of completing the pattern that's identified. And then for processing speed index, the testing involves coding and symbol search. Kaufman instruments are not quite as widely utilized as the WISC and the WACE, but they are still valid intelligence tests for children ages 2.5 to 12.5 years old. The Kaufman Assessment Battery for Children is what it's referred to. There is also the Kaufman Adolescent and Adult Intelligence Test and the Kaufman Brief Intelligence Test, which was designed for people who are between the ages of 11 and 85. The KABC, or the Kaufman Assessment Battery for Children, was developed specifically to evaluate preschoolers, minority groups, and children with learning disabilities. So this test is used to provide educational planning and placement, and it is also often used in neurological assessments and research, and can kind of be used to determine if a person qualifies or needs an IEP in school or qualifies for special education programs. It's also designed for bilingual and nonverbal children. So unlike some of these other tests, there is a complete Spanish edition of the Kaufman instruments that can be used with children whose primary language is Spanish. Then there's the Woodcock-Johnson tests of cognitive abilities, and this is also a set, of course, of intelligence tests. And the Woodcock-Johnson tests include both a standard battery and then an extended battery. So the standard battery of tests consists of tests 1 through 10, while the extended battery includes the tests 11 through 20. There's also a Woodcock-Johnson 3 diagnostic supplement to the tests of cognitive abilities, and it has an additional 11 cognitive tests. And all of these tests are combined, which allows for considerably detailed analysis of cognitive abilities. So this is definitely one of the most detailed methods of measuring intelligence. So this battery of tests assesses general intellectual ability, specific cognitive abilities, scholastic aptitude, oral language, and academic achievement. And it's really broken down into some different test batteries, specifically that address verbal ability, thinking ability, cognitive efficiency, broad reading and math skills, broad written language skills, and oral language skills. And it continues to just break down all of this information. So, for example, there's, one category of tests is all about numerical reasoning. And the questions in the test for this measure involve the test taker determining numerical sequences and also determining small numerical patterns. The visual matching part of the test is addressing perceptual speed, and in this process, the test taker has to quickly find and circle two identical numbers in a row of 6 numbers in 3 minutes. And then another example is the method of measuring mental comparison speed by decision speed. And so in this test, the participant or test taker, they have to quickly look at a row of images and then mark 2 images that are the most closely related in 3 minutes. Of course, there are a huge variety of these different individual instruments. The text covers quite a few of these, and you will also just find that you begin to encounter some of these tests in literature as well as in clinical documentation. Differential ability skills, second edition, is a standard instrument that's utilized, as well as the Slauson intelligence test. The Raven's standard progressive matrices is a really standardized tool that's used quite a bit. The Peabody picture vocabulary test is kind of interesting. It's designed for use for a pretty broad age range. It's like for ages 2.5 to 30 or I think 40 years. And it consists of 100 and something vocabulary items. And the vocabulary test just becomes increasingly difficult as you take it. Basically, test taker listens to the interviewer say a word and then selects one of 4 pictures that best describes the word's meaning. The test of nonverbal intelligence is also a really standardized norm reference measure, and this one is utilized to measure abstract reasoning and problem solving that doesn't require any reading, writing, speaking, or listening. So this test is kind of cool. It's particularly designed for people who do not understand spoken or written English, and that may be for cultural reasons or trauma or disability or an illness of some kind. It's also interesting in that it's a pretty brief test. It only takes about 20 minutes to complete. And it's broken down into these 2 forms referred to as A and B. And those 2 forms are used to establish kind of a multiple measures of a person's ability. And so both A and B each have 45 items with 6 possible response options each. And so if the person correctly or incorrectly answers a question, the test giver assigns them a 1 or a 0, meaning yes or no, essentially. And this test involves things like object recognition and problem solving. When administering intelligence tests in the context of a school psychologist's office or neurological testing, those tests are always administered in an individual setting, as in the test is delivered to one person at one time. But there's also quite a few group intelligence tests, and this is also a method that can be utilized. Group intelligence tests are generally used in mass testing situations, like in school, they're also used in the military. And they're generally more appropriate for adolescents and adults because those age groups don't require quite as much direction or guidance that could be provided in a one-on-one setting for younger test takers. Group intelligence testing is also often quite preferential to test givers because it's more economical, it saves time. But we have to consider the cultural background and language proficiency of each individual in comparison to the group at large. So there are a lot of different group intelligence tests that exist. There's the cognitive abilities test, the Otis Lennon school ability test. There's the NNAT, the multi-dimensional aptitude battery, and the Wonderlic contemporary cognitive ability test. The NNAT is interesting. It's a nonverbal test used for getting K through 12 students into gifted and talented programs. So it's a group administered aptitude test, and it's often given as an entrance exam into schools' gifted and talented programs. And the NNAT, it utilizes shapes and figures to evaluate problem solving and reasoning. And it does this without implementing a bunch of language questions. So this test is really designed to assess how a student thinks instead of what a student knows. Something that we have to consider when working with our clients and measuring an individual's intelligence is the fact that intelligence can be fluid and isn't necessarily stable. Infants and young children, for example, have the least stable intelligence test scores of all age range. And although early research indicated that intelligence gradually declines after age 20, that's of course not supported by later research. So those of us who are over the age of 20 don't have to already be panicking. In fact, more recent research indicates that intelligence gradually increases from childhood to middle age, and then it levels off. And when we do look at those declines in intelligence, they tend to occur in areas of fluid intelligence. And fluid intelligence is the ability to think abstractly and reason quickly and problem solve independent of any previously acquired knowledge. In addition to utilizing intelligence tests as a means by which to better understand an individual or a group of individuals and their intelligence, intelligence tests can be also utilized as a predictive tool. It is widely accepted that test scores can predict school achievement fairly well. So there is a correlation between IQ and school achievement, but we should also be mindful that correlation can emerge because the test items demand the same kinds of learned linguistic and cognitive structures that are how school is constructed. So in other words, IQ tests often test how well you can take a test, and the public school system determines how well you have learned material by taking a test. So if you are able to effectively take an IQ test, then you are probably also able to effectively take a test in your math class. And so there's a correlation, but then of course we also have to kind of take that correlation with a grain of salt. A lot of researchers are looking at other life outcomes that IQ can predict, such as emotional health, social relationships, and physical well-being. One of the most controversial issues in intelligence testing is the question of whether intelligence is genetic or hereditary in some way. So studies have shown that intelligence does have a genetic component, but it is difficult to determine the estimates of genetic contribution to intelligence. Heritability indexes for intelligence tend to be approximately 0.5, which is considerable, but there's just so much else to consider when looking at intelligence. Although there are a lot of studies that have identified some sort of genetic component to intelligence, they haven't really conclusively identified any single gene or genes that have a really primary role in the differences in intelligence. So at this point, the studies are finding that intelligence really involves a lot of genes that each make only a small contribution to a person's overall intelligence. The argument is that genes do make a difference, but they're also not the whole picture, and I think we could have all guessed that. The heritability indexes for intelligence tend to be approximately 0.5. So what that means is that genes account for about half of all the differences in intelligence among people. And that means that half is also not caused by genetic differences, which provides a really strong support for the importance of environmental factors. So genes do make a substantial difference, but they aren't the whole story. A really concrete example could be that a person who genetically has really exceptional eyesight is going to be more naturally rewarded when processing visual information. So their visual processing index may be better developed than other children that lack that genetic propensity towards better eyesight. But this half and half thing about, nature versus nurture, of course, then brings up the nurture. What environmental factors influence intelligence? At the heart of the nature versus nurture argument about intelligence, we look at the question of, are we born with a certain level of intelligence, or do we acquire a lot of our intelligence from our environment, our social environment specific? And this idea is particularly supported by the ACEs study. If you haven't researched it or experienced that study, I do highly recommend looking into that separately. And it's simply identifying a person's adverse childhood experiences. And the study findings suggest that certain adverse childhood experiences, like traumas, are major risk factors for leading causes of illness and death, as well as poor quality of life. So the ACEs study really supports the notion that the development of one's intelligence can be greatly influenced by the experiences that a person acquires over time. And we certainly see this with the clients that we work with, where a young person who's exposed to a considerable amount of emotional or physical trauma is not going to experience the same degree or kind of intellectual development as another member of their cohort. There are also a lot of questions about group differences in intelligence. So specifically breaking down intelligence measures by gender or ethnicity, socioeconomic status. There doesn't really appear to be any general intellectual differences between men and women. There may be a higher propensity for women to be more intelligent in verbal indexes, and men may have a higher propensity for intelligence in visual spatial indexes. When trying to determine any differences in intelligence amongst ethnic groups, this really just becomes a big issue of tests not being culturally normed for the group at hand. So yes, African Americans, Hispanics, and Native Americans tend to score lower on intelligence tests than European Americans or Asian Americans. And those tests are really culturally biased in favor of European Americans or Asian Americans. So a brief introduction into neuropsychology. Neuropsychology is the study of the relationship between the structure and function of the brain and one's behavior. Cognition and physiology are considered interrelated and inseparable. So the field of neuropsych aims to study, assess, and treat behaviors based on brain functioning. Really, the goal of neuropsychology is to understand how behavior, emotion, cognition, and perception may be related to and underpinned by the chemical, electrophysical, anatomical, and integrative functions of the central nervous system. Neuropsych has really been fueled by advancements in imaging technology, and neuropsychological thinking has started to gather a lot of momentum. It really started during the 50s and 60s, and now there has been quite a bit of advancement in this field in particular. Neuropsychological testing is the evaluation of a person's cognitive abilities and their psychiatric personality functioning. And these components of the self are evaluated using a battery of standardized assessment measures. A test battery really involves a variety of cognitive ability areas with more than one test per ability area. And the cognitive ability areas include a person's general cognitive functioning, or their IQ, which we were just looking at, all of these different ways of measuring IQ. That is one large component of neuropsychological testing. And additional cognitive ability areas that neuropsychological testing addresses is processing speed, achievement, executive functioning, a person's attention and memory, their language, their visual perception, their somatosensory function, their motor function, and even their mood and personality. So it really can give you a whole picture of a person that we're working with. Neuropsychological evaluations were really originally targeted to assess individuals who had experienced brain injuries in wartime. Currently, though, neuropsych evals are really useful to assess a whole range of neuropsychiatric conditions, including TBI or traumatic brain injuries, dementia, neurological conditions, psychiatric disorders. Neuropsych evals can also examine the effects of a toxic substance on brain functioning, or can examine the effects of a medical condition. An example of that would be the effects that Huntington's disease can have on the brain. Neuropsych evals help determine a person's competency to stand trial, also determine a person's competency to manage their own financial affairs. Neuropsych evals can also be used to assess a person's ability to live independently versus with supervision, which is particularly crucial for individuals who present with the developmental disabilities as well as the aging population. And the neuropsych evals can also be utilized to kind of rule something out or to help a provider discern between two things that they're looking at. When I worked in a secure psychiatric facility for youth and adolescents, we were routinely referring individuals for neuropsych evals to really help clarify what was going on with them. It was often difficult at that point in the kid's life for treatment providers to discern between a person's cognitive abilities versus their mental health symptoms. And sometimes we didn't know how best to proceed in treatment without that additional information. One kiddo I remember working with was referred for a neuropsych eval, and when he originally came to us from the hospital, his presenting diagnoses were oppositional defiant disorder and PTSD, which, to be frank, was a really common combo that we saw. But when we referred him for neuropsych testing, we really wanted to clarify what was going on with him and kind of figure out what treatment methods would work better for him. He was having a lot of very violent and explosive outbursts that didn't seem to be regulating as much as we would expect with medication and just with the general behavioral support that we could provide. What was interesting is that the neuropsych evaluator determined that this kiddo had a considerably lower full-scale IQ than any of us realized. And in particular, he presented with astronomically low language processing. We hadn't ever considered before that the interventions that we were utilizing, which involved a lot of talking to him and using basic speech, but did involve a bit of speech, turns out that wasn't working because he had such a difficult time even processing the language that he was hearing. We immediately revised his treatment plan and implemented a much more physical treatment approach to our work with him. So there was a lot more that we were able to do with him once we understood what was actually cognitive versus emotional. So that's one example. I mean, other ways in which neuropsych evals can really reveal what's going on for a person is assessing dementia versus pseudo-dementia. Pseudo-dementia is the condition in which depression can cause cognitive deficits that can look like dementia. Neuropsych evals can also clarify a person's amnesia. Amnesia is really the loss of a person's personal or episodic memory, and that may include a knowledge of public people and events. And there are two different kinds of amnesia. There's retrograde, meaning it's the loss of memory for events from your past. And then there's anterograde amnesia, which is the loss of ability to store new memories. A neuropsych eval can help distinguish between the two different memory losses. Neuropsych evals can also be really useful when ruling out TBI versus malingering or unconscious exaggeration of symptoms. For example, a person may exaggerate their mental health symptoms to avoid a criminal conviction, and a neuropsych eval can help clarify what the person's actual state is. Neuropsych evals can also help a provider establish baseline information before a potential problem or before implementing a new treatment. And finally, there's been a significant rise in evaluations for athletes in particular due to the increased recognition of the cognitive implications of concussions. So for athletes who are playing contact sports, there's become an increasing demand for the implementation of neuropsych evals. Neuropsych tests are really focusing on some specific functions of interest. In particular, they're looking at the ability to test intelligence. While there may be more traditional intelligence tests that reveal more about a person's educational background than their brain function, we're looking at these other types of tests that reveal more general analysis and a person's problem-solving skills. And then in a clinical setting, patients undergoing a neuropsych eval may have recently had a stroke or some other medical crisis, which further complicates that intelligence testing. Memory testing is extremely broad and covers 5 distinct types. It covers semantic memory, episodic memory, working memory, priming memory, and procedural memory. So short and long-term memory loss is associated with a lot of different types of cognitive dysfunction. And so a lot of simple memory tests are often standard parts of neuropsychological evaluations to rule out or clarify a particular diagnosis. Language tests are often also integrated into neuropsych batteries, and these tests include evaluating speech as well as a person's reading and writing skills. After a stroke, the brain's language center may be damaged, so language testing is often applied to individuals following a stroke or following any kind of severe accident that may have included a traumatic brain injury. Attention and executive control is also looked at. Executive functions are that umbrella term for a lot of different cognitive processes, including a person's organizational attributes, selective attention, short-term memory aspects, problem-solving, planning. And there's also, of course, the visual perception or visual spatial element of neuropsych evals. And these are the tests that cover the areas involved with visual perception, integration, overall visual construction. Long story short, neuropsych evals are astronomically useful for counselors. We can use the test findings to assist with education for our client and their significant others and family members in terms of helping them understand why they may be experiencing the world a little bit differently, or helping a family member or teacher understand why this person isn't interacting with the world and their surroundings the way one would expect them to. We can really use test findings to guide our treatment goals. And sometimes we can even use test findings as a means for measuring treatment progress. And then finally, it may help us determine the need for a behavioral intervention plan or an incentive plan of some kind.